Hi everyone, in this lesson we want to look at some quadratic functions and their graphs. This is the third in a series, and in this section, in this lesson, we want to look at putting together some of the horizontal and vertical translations and stretches and reflections that we looked at in parts 1 and part 2. Alright, so let's look at the graph of y equals x plus 3 squared minus 2. And what we learned in parts 1 and 2, that if I tweak a function on the inside of it, like x squared with a plus 3, that's going to move it to the left 3. And if I tweak it on the outside with a minus 2, that's going to move it down 2. So this is going to be the same graph of y equals x squared, but it's going to be moved over to the left 3 and down 2. And then I'm going to get my just normal x squared graph that has you go over 1 on either side of the vertex and up 1, and over 2 on either side of the vertex and go up 4. Alright? And so this will be the graph, or at least a sketch of the graph, of this equation y equals x plus 3 squared minus 2. Now, how about if I put a minus in front of this? Well, if I were to just follow my order of operations, first of all, this is still going to go to the left 3. This is still going to go down 2. The minus now is just going to be a vertical reflection. Alright, so if I take my x squared graph and I move it to the left 3, and then I flip it over, then it would look like this, and then if I move it down, it's going to be down here, right? So it's going to have the same vertex point right here, but instead of going over 1, up 1 on either side, I'm going to go over 1 and down 1, and over 2, down 4. Alright, so that's going to look like this. It's the same parabola, and it's even the same vertex in the first one, but it's been flipped over, so it's opening down from this point. Alright, how about if I have a 2 here? Well, again, this is still going to go down 2. It's still going to go to the left 3. The 2, though, is a vertical stretch. So I would go to the left 3 and down 2. And what the 2 tells me here is it's going to open up, instead of with my normal x squared sort of dimension, it's going to be a little skinnier. It's going to stretch this value. When I go over 1, I normally go up 1, but the 2 is going to stretch it up to go up 2 instead of just 1. Instead of going over 2 up 4, it's going to stretch it to go up 8. And that's going to give me a graph that looks a little skinnier. Okay? So it's going to look something like this. Hard to draw with my little pen tablet here that I'm using. But you can tell it's a little skinnier than this one. Alright, how about if I had y equals a negative 1/2 x plus 3 squared? Well, again, I'm going to go down 2. This is going to make it go to the left 3. The 1/2 is going to be a vertical shrink. And the negative, that's going to make it a vertical reflection. So it's going to be opening downwards. Alright, so let's put all that together. I'd go to the left 3 and down 2. And then the negative 1/2, the negative tells me instead of going over 1, up 1, I'm going to go over 1, down 1. And then the half tells me to shrink that to go just down 1/2. Alright, instead of going over 2 and up 4, I'm going to go over 2 and down 2. So I take half of the 4, and then the minus tells me it opens down. So notice that makes it open downward, and it looks a little fatter. Okay? Again, it only looks fatter because it's a shrink and it's opening down. And I typically, we're not concerned so much about the specific points as we are just getting a basic sketch. If I want exact points, I can always plug these into my graphing calculator and get a good graph there. All right, now let's look at these And notice that in every one of these equations, the vertex is the same, right? The vertex is going to be over to the left 3 and down 2. So negative 3 and negative 2 is the vertex for every one of these. Notice the domain is the same for all of them. It's all real numbers, right? You can plug any value of x in for every one of these. The range is different though, right? Here the range, the only y values I'm getting out of the first one are from negative 2 to infinity. And here the only range values, only y values I'm getting out are between negative infinity and negative 2. Here I'm just getting y values out from 2 to infinity, negative 2 to infinity. And here I'm just getting out y values from minus infinity to minus 2. Notice in all of these also that there is an axis of symmetry that goes right through the vertex. Let me make that a red color there. Okay? And that parabola is symmetric about that line. And that's the same in all of these. It goes because the vertex is the same in all of them. The axis of symmetry is x equals negative 3 in this case. Okay? And then one other thing to notice is that each of these has either a maximum or a minimum value. If the parabola is opening upwards because this number right here is positive, then there's going to be a minimum value. So in this first one, there's a minimum value of negative 2 at x equals negative 3. Whereas this one, because it's opening downwards because of the negative right here, then that vertex is going to be a maximum value. Notice that the minimum or the maximum value is always going to occur at the vertex. So this one has a maximum value of negative 2 at x equals negative 3. And this one here would have a minimum value. Again, the minimum value is the y value of negative 2, and that occurs at x equals negative 3, and this one's opening down, so it has a maximum value. And again, the y value, the biggest the y value ever gets is negative 2, and that occurs at x equals negative 3. Okay? All right, let me look at a couple more problems with you here. It says identify the vertex of the quadratic function and then sketch the graph. So in general, if I have a quadratic equation that's written in this form, I can see right away that this is going to go to the left 1 and up 4. So that tells me the vertex is negative 1, 4. So what I want to train my eye to see is I can just look at this and see I know my vertex is negative 1 because it goes to the left 1 and positive 4 up 4. All right, and if I wanted to sketch it, the minus 2 tells me that it's going to be opening down and kind of skinny. So all I have to do to sketch the graph of this is go to my vertex, negative 1 and up 4, and then draw a graph that's going down and skinny. Now if I want to be a little more exact, I'd go down 2 because of the 2 right here. And just a couple points, that's enough. It'll look something like this. Okay, this one here, I can tell that this is going to go to the right a quarter and down 5. So I know that the vertex is going to be 1/4 to the right and then negative 5. So this is going to look like this, 1/4, so this would be a half, and a quarter would be right here, and then down 5 puts me right down here. So here's my vertex. And then the 6 tells me that's going to open up and it's going to be really skinny. And if I want to know how skinny, I'd go over 1 from that vertex and up 6. And over 1 in this direction, up 6. So you can see that's really skinny, isn't it? And it doesn't have to be, usually when we're doing this by hand, I just want to sketch. So you don't have to get too carried away with your accuracy here. But it does give you an idea of how skinny that is. the last one here I want to look at, hopefully you can see it's going to go 2 to the right, so your vertex is going to be 2 in the x direction and up 1. So my vertex will be here at 2, 1. And then the minus 1/3, that would tell me that it's going to open down and make it be sort of fat. So if I wanted a point to grab onto, I'd go over, you know, to the 1 and on either side of the vertex, and I'd go down 1/3, and that'll give you some idea of the fatness of it. But as far as other points, just draw it so it's sort of fat, and you have a picture of at least a rough sketch of what that will look like. Okay?